So the chain rule that we learned in the last video, we can extend it out to a function of any number of variables. So before it was stated just for a function of two variables, but you could have a function of any number, x1, x2, all the way out to xn, and then dw dt would be the partial derivative of w with respect to x1, the derivative of x1 with respect to t, the partial derivative of w with respect to x2 times the derivative of x2 with respect to t, so d, plus, and keep going until you get to the very last term, the partial derivative of w with respect to xn times the derivative of xn with respect to t. So previously, our previous example, we only had two variables, but you could have a finite number of variables. So let's look at the following example here. I'm going to tell you that two objects are traveling in elliptic paths given by the following parametric equations. So those equations are going to be x1 is 4 cosine t, and y1 will be 2 sine t. These are the equations for the first object. And then for the second object, x2 will be 2 sine of 2t. And the y equation, y2, would be 3 cosine of 2t. These are the parametric equations for the second object. And I want to know at what rate is the distance between the two objects changing when t equals pi. So the distance between these two objects, well, it's the distance between really 2 points. So our formula S will be the square root of x2 minus x1 squared plus y2 minus y1 squared, which I'm going to go ahead, because we're going to take derivatives, I'm going to go ahead and write S with a 1/2 exponent to the 1/2. And then I need to know, I'm told t equals pi, but I need to know the position of these objects when t equals pi. So you're going to go back to your parametric equations up here and plug in pi into those. So if you plug in pi, you'll see that x1 is 4, y1 will be 0, x2 will be 0, and y2 will be 3. Okay, and now I'm also going to need the partial derivatives of S at t equals pi. So I've got my position of my objects there, but I need to to have my partial derivatives. So I'm going to take the partial derivative of s with respect to x1. So we're going to have to do the chain rule here, 1/2, just the regular chain rule, plus y2 minus y1 squared. My new power will be -1/2, but I have to multiply by the derivative of the inside, and the inside with respect to x1. So really only this part right here has an x1 in it, so I've got to do just the regular chain rule, 2x2 minus x1 times the derivative of the inside with respect to x1. The derivative of the inside here with respect to x1 is going to be a -1. So if we simplify this, let's see, I'm going to get negative x2 minus x1 all over the square root here. Square root x2 minus x1 squared plus y2 minus y1 squared. So that's the partial derivative of s with respect to x1. And you can plug in your points, your values for up here for x1, x2, y1, and y2. If you do that, in the top you'll get negative -4 over the square root of 4 squared, which is 16, 3 squared, which is 9. You'll get positive 4/5. And then you need to find the other 3 partial derivatives. So the partial derivative of s with respect to y1, I'm just going to tell you what it is. It'll be negative y2 minus y1 over this square root. And if you plug in your points, your coordinates, you'll get -3 over 5 for that. The partial derivative of s with respect to x2 will be x2 minus x1 over that square root. And if you plug in your point, you're going to get 4 over 5 there. And the final partial derivative will be the partial derivative of s with respect to y2, which would be y2 minus y1 over that square root. Again, plug in your values for x1, x2, y1, and y2, and you should get 3/5 for this. So you've got your partial derivatives. Now you need the following derivatives, dx1 dt. If you remember, x1 is the formula for cosine t, so the derivative of that would be -4 sine t, and plug in t equals pi into this. You'll get 0. y1, the derivative would be 2 cosine t, plug in pi, you'll get -2. Take the derivative of x2 with respect to t, the derivative would be using the chain rule 4 cosine 2t. If you plug in pi, you'll get 4 for this one. And the last one will be dy2. The derivative of y2 with respect to t should be -6 sine of 2t. Plug in pi, and you'll get 0. So now we just need to use our chain rule formula here. So ds dt, it's the partial derivative of s with respect to x1 times dx1 dt, the partial derivative of s with respect to y1 dy1 dt, the partial derivative of s with respect to x2 dx2 dt, and we need one more term plus the partial derivative of s with respect to y2 dy2 dt. And then we just plug in all of these things that we previously found. So we had negative 4/5. This one was, I'm going to fill in our partial derivatives first. 4/5 and 3/5. Now fill in our derivatives. So we had 0, -2, 4, and 0. Those were the last things we just calculated. So in the end, if you simplify this, you'll get 22/5. And that's ds dt when t equals pi.